so I hand over to you.
Thank you. So, thank you again. Welcome again. So, from my side now, it's a pleasure to present you a little bit our challenge on our hands-on sessions, which we set up during the last 3 months, something like this, together with our TU Munich colleagues, with Siemens colleagues, and you will see these are really business-orientated challenges, the first two, and the second and third and fourth is then more correlated from TU Munich and in another project together with our colleagues from France. So, and it's not my part to really go more deeper inside the challenge. No, we have the team leads here, which talked a lot in the last months about the insight or the topics which we set up there. And the idea now is to show everybody here the challenge and the topics more in detail. Okay, then maybe only a few words. I split this presentation in 2 points. First will be the challenge, and afterwards we will show you some pitch introduction. Because the idea is that you will pitch your results on Thursday in front of a jury. You will also see in a few minutes who is the jury. And but before I said it, we would like to start with the presentations of the challenge. And the first one is a topic correlated with the HEV, and more details and more insights we will get from Florian.
Hey, my name is Florian, and this is the challenge you will be doing with me. We have here the HEV. It's right next to us here. We have a huge area. We are working together with the challenge 2. But our main goal is here that we brought an HEV with us that has like sort of 100% Siemens in it. We have the Open Controller, we have the new micro drives, we have some scale-ins, we have the edge box, we have the new AI module. So all the hot topics are in one little product, and it moves right now with a controller. But the goal of this challenge is that this robot will drive on its own to a shelf box, where we then get the nice little gift from challenge 2. But here we have different parts. The one part is with the AI. We want to detect a traffic cone, red and white, and the HEV must find that via an artificial intelligence, and then it knows, okay, the cone is somewhere around 2 meters this direction, and we have to automatically drive there, and in order that we can just tell the robot, hey, you have to go 2 meters this direction. We have to learn a little bit about ROS, about the robot operation system. And so basically it's like 2 big tasks. First, get to know with ROS, get to know the basics, get to know where are the problems that are currently solved by normal algorithms, and then we start hacking with AI and see where it leads us. And I'm happy that you're all here.
Thanks again. So then let's come to challenge number 2. Johannes is our team head and team lead, and he will give you some more insights.
So hi, I'm Johannes. I would also like to welcome you here. In our challenge 2, we will cooperate together with challenge 1 with the HEV, and we have here a Siemens robotic arm, which is controlled by MoveIt and ROS, and we use for vision. We use a 3D camera, which is connected to the Siemens neural processing units for the object detection and also for the grasping of the object. We want to grasp within a shelf a Kellogg's package and put it on top of the robot. So we have there different parts. We will use we'll create some trajectories for the robot arm together with MoveIt, with the grasping. And also we want to train different networks together with the neural processing unit from Siemens and combine the things together. And we will use as a controller or the so-called Open Controller 2 from Siemens, which has on the one side a software PLC, and on the other side there's a Linux operating system. Yes, so that is our goal, and challenge 1 and challenge 2 are quite connected to each other. Yes, thank you.
Perfect, thank you. You also heard something about the NPU, the Neural Processing Unit. We will have tomorrow after lunch an introduction, a hands-on introduction that you understand a little bit more what it means. So it's a edge device where you can implement and set on neural networks. Okay, that's to challenge 1 and 2, and maybe the not so attractive part now. I sent last week on Friday NDA to you because you saw it. This 1 and 2, challenge 1 and 2 are really correlated to our business activities, and all the groups will have more information, some confidential information, and that's why we would like to set up later during the day such a kind of NDA, but it's only on challenge 1 and 2. And if you would like to work afterwards at the university on such topics, you are really welcome. Our colleagues would like to support you there. But here it's more the idea that you not go to the next company and say, here, let's set up such a topic like what we did with Siemens. Yeah. So that's the not attractive part. And now let's come to the next challenge. It's challenge number 3. And our team head is Stefan Liebald.
Thank you. Hey, yeah, my name is Stefan, and I'm responsible for challenge number 3, which is implementing a full IoT processing chain from sensors to visualization. And maybe some, or hopefully even most of you already saw our demonstrator back in the top at that table, where also challenge team number 3 will work then later on. And also Mark Oliver already talked about the demo itself and also the VSL middleware for IoT that he will also use to build multiple microservices that build or that are composed using the VSL to a complex workflow, building that game. So in brief, what we have behind are we have 2 Arduinos with some sensors, so a light sensor on it, and 2 LEDs. And both of them are connected using microservices to the VSL, and then we have a game logic service that can interact with those services and, for example, read the state of the light sensor. So you can, if you put your hand on the box, you will get the result, okay, now it's dark, and the game logic checks, okay, if both boxes are dark, then you start the game, and at some point the LEDs light on the different boxes, and then you have to remove your hand as fast as possible. And then we have also, for example, a leaderboard service, and the game service then reports the result to that leaderboard service. And we have some other services, so you can see them behind, or you can't see the services, but you can see the hardware and how they interact. And then we visualize the results. If there are no talks currently, you can also see it there on the beamer in that nice leaderboard or web wall where you see the videos and the leaderboard and so on. And well, the topic of challenge 3 is basically you will build a similar game using different hardware. So what we have are likely 2 of those leaps. So who knows what the leap is? Much not at all. So basically it's just a sensor, so you have it lying around basically, and then you can move your hand on top of it, and it recognizes kind of what gestures you're doing, what your hand is looking like, and so on. So you can integrate that instead of our brightness sensors, that you recognize different gestures or similar. And then based on those, you can also implement a similar workflow. So what we propose is to split that into 3 teams. So one team, so I think we have currently 5 people, one team concentrates on the leaps, so how to integrate the leaps in that middleware. Another team looks at the back end, kind of the game logic, so how to implement, you get the input from the leap, how do you implement the game logic, what to do at which state. And then also the front-end team, which creates a nice visualization, also puts out commands in the browser, for example, or in the terminal to display, okay, what should you currently do, or what should the players currently do. And yeah, I mean, you can do that pretty much straightforward. You start by basically rebuilding our game, but just use leaps, and just if there is any input, you act. And once you have that, you can get more and more complex to check, like, okay, if you have certain gestures, if you have certain positions with your fingers or similar. And well, I mean, the main part tomorrow will first coming up with a cool idea how you can build a game using those leaps. Okay, that's it for me.
Thanks. Okay, and now let's come to the last challenge. It's challenge number 4. Our team head is Alexandre Marquardt. Okay, yeah. And yeah, he's there.
So yeah, hello everyone. I cheated a bit. I have some slides, not only one, but it's gonna be okay. We'll be on time to go and drink beers. Basically, for this challenge, I will have to make a air quality sensor. Why air quality? Why not? I mean, maybe in this room we are slowly dying and we don't know it. So at the end of the challenge, some will be able to say if yes or not we are dying here. So you are basically given one card, which is a microcontroller. So it's either a PyCom board, which is programmed in MicroPython, or something more industrial in the form of a Siemens device. I don't remember the exact, but IoT 24. T. And it's programmed in, it's actually a Linux board, and so yeah, it's more industrial. So the sensor in itself have many sensors, and too many actually. You have a GPS, you have a screen, which is not a sensor by the way, I know. You have a total volatile organic component sensor, which is what sense if the air inside is good to breathe or not. Temperature and humidity sensor, and a fine particle sensor for outside air. So all of this consumes a lot, even more than transmitting data with LoRa, which is, by the way, the wireless technology we use to transfer the data. So you will have to do some choices if you want to stay on battery, for instance, a long time. Okay, also if you don't want to exceed your MTU, packet MTU, maybe you will have to think about what kind of data you want to measure more often or not, right? So yeah, it's basically the same thing I just said. So the perfect weather metering station, it will run forever on battery, so you can put it everywhere. So this is not true, obviously. It collects huge amounts of data. This is not possible because on LoRa and LoRaWAN, any network, actually, you are limited in terms of size of packets. And sends data regularly, this is more likely to be achievable, right? Then the data, and this happens behind the curtains, but your data goes into the LoRa network, which is given by Aclio, thank you. And we do the processing so that it's stored in a nice web interface provided by Adafruit. And from there, for those who are curious, you can actually retrieve the data with a REST API. Otherwise, just look at the graphs, it's nice. And there will be a map also. So you can track if your device is working or not in real time, slightly real time, right? So we have challenges inside the challenge. So it's not possible to do the perfect sensor, right? So you'll have to focus on having at least one of this challenge. You have to be at least the best in one of these challenges. So the first one is data diversity. That means, did you use all of the sensors or only one or only a few? Do you send data regularly? For example, if you put your device, you know it's always close to the antenna, then it will be very easy to regularly send data, let's say every minute. But if you choose to move around and do some tests, then obviously sometimes you will run out of coverage and your data will not be sent so regularly, or at least it will be sent maybe, but not received. Data quantity, so that is for the people who want to send the maximum amount of data, so it doesn't have to be regular, but it has to be massive. So this limits, for example, geographic movements also, and you have to be close to the gateway to have the maximum MTU and bit rates. Data localization, this is for people who like sport and wants to go around the city as far as they can to gather the data in the most underground part of Munich. I don't know the city too well. And finally, code quality. So at the end, we will just go through your code, and the one which is the most well documented, easy to understand, will win this prize. And that's it. Thank you.
Thanks a lot.